For example 2, it is slightly different because we have a piecewise function. Our ft is a piecewise function. Okay, so now we want to find the Laplace transform of ft. Okay, so by definition, it is the integral from 0 to infinity exponent negative st times ft dt. Okay, but in our case now, we have 3 ft, okay, which depends on the certain interval. So it means that we need to have a separated integral. Okay, so look at the first interval. Okay, so we have 0 to 5. T is from 0 to 5. Okay, so by the definition, so we need to have exponent negative st times ft. So for this interval 0 to 5, our ft is 2. So I can write 2 to be somewhere here. Okay, so we have 2 exponent negative st dt. Okay, and then for the second interval, it is from 5 to 10. Okay, exponent negative st times our ft in this interval is 0. So, okay, and then we have dt. And then we can see that this part is actually 0. We can cancel out, okay, because 0 times exponent is 0. Okay, that's for the second interval. So basically, you just can ignore the second interval. Plus, the third interval is t greater than 10. It means, okay, if we want to write in terms of greater or less, okay, so it should be t greater than 10, okay, and less than infinity, okay, because it starts from 10 and upwards, means up to positive infinity. So the interval on the integrand is 10 up to positive infinity exponent negative st times our ft in this interval is exponent of 4t dt. All right. So now, for the first integral, we have 2 exponent negative st over negative s. Okay, so remember we integrate respect to t, not respect to s. So we evaluate from 0 to 5 here. And then for the third integral, so we have limit for k approaching infinity, the integral becomes 10 to k. Okay, so remember, just like in example 2, we need to take out negative t so that we have in the bracket we have negative s plus we have s minus 4. Okay, so if we expand the term in the bracket, so we are going to have exactly the original term here. All right, so by that, okay, evaluate the first integral. So you can put aside negative 2 over s. Okay, so in the bracket I have when t equals 5, then we have exponent negative 5s minus with a, and then when t equal to 0, we have exponent of negative 0, which is 1. Okay, so we have that. And for this one, okay, the limit follows. Okay, so that integral, okay, is now exponent negative t s minus 4, but don't forget we need to differentiate negative t s minus 4 so that we have negative s minus 4, and then we evaluate from 10 to k. Alright, so be careful here. Sometimes students overlook, okay, they tend to write 0 to k. Okay, so we have now negative 2 exponent negative 5s over s plus 2 over s if we expand the term in the bracket. And then for the limit, we have limit k approaching infinity. Okay, so see, we can put aside the 1 over negative s minus 4. Okay, so I can have 1 over negative s minus 4. Okay, and then when t equals k, then we have exponent negative k s minus 4, and then minus exponent negative 10 s minus 4. All right. Okay. In fact, the correct way to write it, so basically we can put aside this fraction before the limit. Okay, we can put in front of the limit. Okay, so this part here can be put, okay, in front of the limit. Okay, so with that, we can see when k here is infinity, then we have exponent of negative infinity, which is 0. So basically, this part is 0, right? So at the end, our final answer should be negative 2 exponent negative 5s over s plus 2 over s, okay? And then we have the fraction here, okay, and this is 0 and this is negative, okay. So since this is negative, okay, multiply with the negative here, so we have positive. So plus, okay, 1 over s minus 4 exponent negative 10 s minus 4. Okay, so now let's think, what is the condition for the s? Okay, look at this exponent negative ts minus 4. Okay, so in order for this problem to have the solution, okay, the exponent here cannot be infinity. Otherwise, the result will be all infinity. Okay, so this value here, so basically need to be negative. Okay, so s minus 4 will then should be positive. Because if s minus 4 here is positive, then you multiply with the negative k, then you will have negative. When k is positive infinity, then you will have exponent of negative infinity. Okay, so s minus 4 should be greater than 0. So it means, okay, s minus 4 should be greater than 0, which can be simplified as s should be greater than 4. Okay, otherwise we don't have the solution. If s is less than 4, for example, okay, so take, for example, s is 2, then this part here will be negative 2. And then negative 2 multiply with the negative k, then you have positive k. So when k is infinity, then you will have exponent of positive infinity, which is infinity. Then you don't have the solution. So in order to have the solution, in order to make sure the solution converge, then s minus 4 need to be positive, because later on we want to multiply with a negative k. All right, so I hope that part is clear. But normally in the test or in the exam, we don't really strict on the value of s here. So normally when the student answer up to this, then you already have the full mark. Okay, right.